Hello everyone, I'm back with another Leetcode problem. Today we are going to discuss problem 57. It's an interval problem. It's a problem within the blind 75 list. And so the problem description says that you are given an array of non-overlapping interval. This is important. So you are given array or multiple intervals and each of them are non-overlapping. So you know what an interval is, right? It will have a starting point and an ending point. Um, so, and the intervals and the array is actually sorted ascending in an ascending order based on the start point. And so this is what you are given. So for example, you are given this intervals array. You see we have two intervals and these are sorted based on their start point. So you see this one comes first because 1 is less than 6. Okay. And the second thing that you are given is a new interval. So what you have to do is you have to insert this interval into here. Okay. And you have to do it in such a way so that if this interval itself is like a non-overlapping, you can just say if this interval was something like this, if it was say 4, 5, right? So you have to just add this 4, 5 here, right? But if it's overlapping with anything, for example, here 2, 5, you see it's overlapping with 1, 3. So you have to extend, merge them, and then add them to the result. So 1, 3 and 2, 5, they're merged together to make like 1, 5, right? So the result becomes 1, 5 and 6, 9. So how do we solve this problem? So before starting solving it together, I suggest everyone to think about it and then we can discuss it together. Okay, so if you are back, you see here that I have drawn all the intervals from example 2. So you see all the intervals are like 1, 2, 3, 4, 3, 5, 6, 7, 8, 10, and 12, 16. You see there are like 5 intervals. They're sorted based on their starting points, and all of them are non-overlapping. And then we're given a new interval for 8. So we have to insert this interval into these and then get a final result, right? Okay. So I have actually drawn them. To draw for my ease, I have drawn a timeline and then I have drawn all the intervals. So this is the new interval that I have. So this is the new interval that we have to insert. Okay. So how do we do it? So the first thing to remember here is if this new, like, okay, so all the intervals that are not overlapping with this new interval, they will go directly to the result, right? Go directly to the result. So what we can do is we can actually keep on selecting intervals one after another and see if they're non-overlapping. So you can see here that this one actually ends here, right? So this is not overlapping with this one. So this one and also this one, these two are not overlapping. So first, if there is any existing interval that is not overlapping with the new interval, we can actually add them to the result, right? But there is a procedure to check that. So the first thing we have to do is for the new interval, let's say we have a beginning point and an ending point, right? So the beginning point is 4 and the ending point is 8. Now, one after another, we will check these candidate intervals, right? This one, and then we go to this one, then this one, then this one, then this one. We'll check if they are overlapping with the new interval. If they are not overlapping, then we do something. If they're overlapping, then we'll do something else. Okay, so let's say our answer is here. Okay, so how do we check? So this is the first interval. How do we check if this one is overlapping or non-overlapping with the new interval? What we do is we check the end point, right? End point of this interval with the beginning point of the new interval. And we see that the end point is smaller than the beginning point, right? In that case, it's straightforward. We just add this candidate interval. We call this a candidate interval. to the answer. So because this one is not only non-overlapping, this one also ends before the new interval, right? So we don't have to worry about anything. We can just directly add it. Okay, but the same thing won't work here. Just notice carefully. We have to do a little bit check here. So for this case, we check if the beginning of the interval is greater than the end of this interval. So you see this one is actually greater than, right? So there is no overlapping. Okay, now we know that we can also add this to the answer, but before that, we have to make sure that this one is already added. I cannot add this because we have to keep this thing sorted, right? I cannot just add this and then add this, right? I cannot do that. So I have to first check before adding this one, I have to check if this one is already added. So we keep a flag, say added. Let's keep this flag. So this flag is first false. So if this flag is false, we have to add this thing first, like 4, 8, and only then we have to add 12, 16. Okay. Okay. So that's not the end of the story. So these are the two non-overlapping cases, right? The first case is if the ending point actually if the ending point is smaller than the beginning point of the new interval, then we add this directly, right? The second case is if the beginning point of the candidate is greater than the ending point of the new interval, then also this one is going to be added. But before that, I have to check if the new interval is already added or not, right? Okay, so these are the two non-overlapping cases. Now let's talk about the other cases. If none of these two cases are true, then we know that the current candidate is actually overlapping. So you see, we added this. Now we moved on to this, right? And this one actually, the beginning point is not greater than the end point of the new interval. Neither is the end point is smaller than the beginning point. So this one is actually overlapping. So if it's overlapping, I have to start creating, like I have to start merging with this one, right? I have to start merging. So how do I merge it? So the way I merge it is I take the smaller of these two, right? Smaller of 3 and 5. So you see smaller than 3 and 5 is, so smaller of 3 and 4. The smaller of them are like 3. And then I take the larger of 5 and 8. So you see this is 8. The larger is 8. That means merging these two actually gives me a new interval, which actually extends from 3 up to 8, right? 3 up to 8. So we just forget this one. We forget this one. This is no longer the candidate. We forget this one. We are now dealing with these interval like 3, 8. We are dealing with this interval 3 to 8, right? Okay, so can we add 3 and 8 directly to the answer? No, not yet. We have to, because these 3, 8 might be overlapping with other intervals. So we have to move to the next candidate. Now, next candidate, you see this one is not non-overlapping. It doesn't follow any of the rules here or the rules here, right? So this one is also overlapping. So what we do is we keep on merging, right? So we keep on merging this and this. Now you see the smaller of 3 and 6 is 3, and the larger of 7 and 8 is also 8, right? So that means the new interval still remains the same, 3, 8. Okay, next I move to the next candidate. Okay, next candidate, you see 8 and 10. Okay, so 8, this one actually is the same value with the endpoint. That means this one is also overlapping. So I do another merge. So how do I do the merge? You see the smaller of the 3 and 8 is 3, that is fine. but the larger of 10 and 8 is 10, okay? So basically, the new interval is now expanded from 3 to 10, okay? So I have done merging this. Okay, next I move to this one. Now you see that uh, 12 is smaller than 10, right? 12 is smaller than 10. So that means this is not overlapping. So this is non-overlapping with the previous interval. So next what I do is I add this 310 first, because this is not added. I set this to true. And then I add this. Okay. So I add this 1216. Okay. So we are done. So the time complexity, you see, if we have like n intervals, we were actually dealing with each interval just once, right? And meanwhile, like, we are doing our like merging everything. So it's order of n time complexity. The space, well, we are not using any extra space. So yeah. So just for this one, we are just using a constant space to keep track of the merging, right? So it's a constant space. So the space is order of 1. So let's take a look at the code. You see if the intervals array is null or empty, we just return null. There is nothing to insert. And then we have a list. This is for the result purpose, right? We keep an array list of integer arrays. And then actually we do a sorting. Basically, we don't need to do the sorting because it says the intervals are actually sorted already. So let's leave this line. And then we have to, like, you see that we have to keep track of whether the new interval is already added or not. I explained in the explanation, so we keep it to false. And this is the index of the current interval or the candidate interval. We keep on checking every interval and decide on that from, right? So, and we'll keep checking on all intervals. So we run a while loop, and this while loop will run until we are exhausting all the intervals, right? Okay. And first we check if there is the non-overlapping case. So this one is if the end point of the new interval is smaller than the beginning point of the candidate interval, that means there is non-overlapping. Now this one is going to be added, this interval, right? This candidate ith interval is going to be added to the result. But before that, I have to check if the new interval is already added or not. If the new interval is not added, first I add the new interval and then set the added flag to true. Okay. Otherwise, if this is added, only then I actually change the candidate, like add the candidate interval and change the value. Okay. So that's the only place we do it. And then we go to the back to the beginning of the for loop. The other non-overlapping case is if the candidate interval ends before the new interval, right? If the candidate interval, if the end point is smaller than the beginning point of the new interval, in that case, we don't have to worry about anything. We just add the candidate interval to the result, increase the value of index I, so that next time the next interval becomes the candidate. Done. Okay. So it comes to the third point, else. So that means these two non-overlapping cases we checked, nothing happened. So we are here. That means this is overlapping. This candidate interval is overlapping with the new interval. So we take the start point, the minimum of the starting point of the two. We take the end point, the maximum of this starting point, and we cannot stop there. We have to keep on merging all other intervals that are that are actually overlapping. So we run a while loop, and the value of I, we have to make sure that we don't go beyond the length of all the intervals. And we keep on doing this until this new endpoint of the new interval is still bigger than equal to the beginning point of the new candidate, right? Until that happens, we keep on changing the endpoint. We keep on changing the endpoint, right? Okay. And finally, we have, when we are here, we have the start point and the end point of the newly merged interval. We add that, make the added value to true, okay? And then we go back here to the beginning of the while loop. Okay, so there might be a case that even after you do everything, your new interval is not still added, right? In that case, you have to check if still it's not added, you add to the interval. Okay, so if we had our new interval somewhere here, right? So it have been added this, but it's still the new interval. It wasn't overlapping with anything. Still, it's beyond the boundary. So that's why the last line, we have to check if after doing like checking all the candidate intervals, if the added flag is still is not true, that means the new interval is actually all the way to the right. Okay, so in that case, we have to add that new interval and end our code there. And finally, we return our result. We convert the list into an array because we have to return an array, two-dimensional array as the result. And that's it. So thanks everyone for watching. We will come back with another problem next time.